Hello, good morning. We are waiting still people to come in. We are 1 minute in advance. That is extraordinary for Italian, but just for starting. My name is Giovanna Giuffrè. I am from ISINNOVA, a consultancy based in Rome. I'm very happy to be here today and moderate a discussion on soil intelligence for public good, advancing a fair data and knowledge infrastructure for healthier soil. So the basic of this discussion is that we know that soil health needs more data that need to be trusted, accessible, connected, and these are the basis to have better soil health, better land management, and more evidence-based policy. But it is a challenge. Data are fragmented, knowledge is still limited, and there is still also resistance between privacy and, let's say, common good. I start with a joke because it's also a way to icebreak a discussion about the fear of artificial intelligence, but also how this is connected with human intelligence and the ability to ask the right question and to evolve together with the amount of data that we will have now and in the future. Just a brief recap of how this webinar will be managed. I'm very happy to be here with two representatives of projects that are highly connected with data gathering and sharing. So Radu Giurgiu from ILVO, the Flanders Research Institute for Agriculture, Fishery and Food, and project coordinator of SoilWise, and Octavian Chiriac, that is agriculture researcher with a background in agronomy, soil fertility, and digital agriculture at OpenGeoHub. We will have as a house, let's say, as an organization, two short presentation and then a moderated discussion. It's quite brief. It's 1 hour webinar, but we would love to hear from you. So if you're listening the presentation, you have a question, doubt, idea, project you work with that you would like to share also the result, please write your question in answer and box question. And just also an introduction, this webinar is hosted by OpenGeoHub, that is a partner, one of the main partner of AI for soil health. Is a project derived to build a European-wide digital infrastructure to monitor soil health metrics, and we'll hear more also in the presentation by Octavian on the result. But the result is a quite broad project with 28 partners representing 13 pedoclimatic regions. Is coordinated by Aarhus University, and we are almost at the end of the project, so we'll be able to present partial result of this work that has been carried out from 2023, and now in 2027 will end. The approach is really top-down, so looking more European-wide infrastructure more than regional. So this with the opportunity and limit of this kind of approach. And just a framework on what are the data for that can help also to read the discussion and raise your question. So we know we will have more data, but how this data will be used depends a lot on the user perspective, and sometimes we underestimate the needs of the different user and the ability to interpret them. So question also on the skills and knowledge that we need to create to be able to read the data. And it's different if you are a scientist, a stakeholder that want to act upon the land management, or a decision makers, and also the territorial level you work with. If it's more a local, regional, Europe, and here the tension between privacy also and let's say public good emerge quite clearly. That is a very short introduction. I think I also stay within the time limit, and it is a big thing. So I'm very happy to give the floor for a first presentation to Radu, and that will present SoilWise Project and all the work that have been carried out in the last years. Radu, the floor is yours.
Thanks a lot, Giovanna. Hello, everybody. Thank you for the introduction and thank you for the invitation to this webinar. I think AI for Soil Health and SoilWise are very complementary projects, so I'm really also looking forward for the discussion after the presentations. But in short, I would like just to present a bit the SoilWise project and what we're trying to obtain there. I think if you're in this webinar, you might know about the problem context. So in Europe, according to the European Commission, more than 60%, 70% of the soils are degraded, which results in an estimated cost of 50 billion euro per year for the European Commission. There's a lot of efforts to try to reverse this trend to make soils again healthy. One of the way is to invest in research and innovation. So it's foreseen something that around 1 billion euro investment in this mission Soil Deal for Europe. Besides the research and innovation projects, also 100 living labs and lighthouses are foreseen. So there will be a lot of data, but also knowledge on how to improve the soil health in Europe generated in these projects. But the problem is still there. The data and the knowledge is mostly fragmented and hard to find, poorly described, very difficult to reuse. It's not interoperable. This is something that comes from long time ago, but even now with the new projects, this is the case. So what we're looking towards is to move towards a fair data sharing supported with co-design guidance and capacity building, and to move from these scattered efforts to interoperable and sustainable soil data and knowledge system. And maybe in more simple words, we're looking how to make the soil information fair, so findable, accessible, interoperable, and reusable. And in this context, the SoilWise project started. It's already since 2023, and it goes until August 2027. The main objective is to develop, test, deliver a prototype for long-term soil knowledge and data catalog. This metadata catalog will become part of the European Soil Observatory. So the things that we are developing will be migrated and integrated in the new EUSO. So we're working very closely with JRC. We are 15 partners from 9 countries, and we are a mix of technical developers and people working closely with the stakeholders to get the requirements and also validate the things we are developing. Maybe a bit how we are working is that we work in iterative cycles. We have 3 main cycles. So in each cycle, we deliver a prototype. And each of these cycles is consisting of 4 phases that repeat every time. So in the beginning, we are co-designing, meaning that we're working with different stakeholder groups that I will show in a bit, trying to understand what are the needs and problems they are trying to solve. So these are translated into technical requirements. So this goes then to the development phase. Based on these requirements, we're trying to develop the catalog and the backend and the interface to serve these needs. And then the third phase is to integrate all these components together and also validate back with the stakeholders to see, are we close to what was desired, what else we can improve. And in this phase, we're also looking at what are the, like, say, success stories, and then we demonstrate them to a larger audience for those target groups. So we have demonstration events after each end of each cycle to different groups such as farmers and advisors, policymakers, researchers, also industry, living labs, and so forth. And right now, we just finished the second cycle of development, and we're moving towards the third and final one. So maybe even simpler, we're now in the last development phase. We're really moving towards the vision of what we want to deliver at the end of the project. And in parallel, we're starting to migrate the developments towards the EUSO and test how it works there, with the goal by the end of the project to have this done and also been already integrated with EUSO, because then the JRC and the European Commission will further maintain and develop it in the future. Although we're very focused on developing a software product, basically, we're a very user-driven process. So we have a lot of stakeholders. We have these groups that I already talked about, the researchers, living labs, farmers, and so forth. But there are also more than, I think, 70 mission soil projects right now. And they all produce different type of data and knowledge resources, but they also have their own requirements, wishes, and different experience with data management. So we try to take in account all these wishes and ways of working. The Commission is also organizing a mission soil cluster on knowledge and data management that we co-chair together with JRC, where we try to bring everybody together and align what are the best practices, how everything works together, and what they would need to do to be sure that the records will be available in SoilWise and later EUSO. And also with the European Commission, I already mentioned JRC, but also DG Agri and REA, we're working very closely to be able to achieve this, let's say, ambitious objectives. What we provide, but is maybe most visible, is the SoilWise metadata catalog. The Soil Companion is a chatbot that is aiming to translate the information from the catalog in a natural language, but we are also working on supporting the ones that are providing the data and knowledge with the strategy and guidelines to help them facilitate in this process. This is a simplified schema to show how it works. So basically, a soil data or knowledge provider. So data can be any type of data sets, but there are also different soil information that are relevant, can be policy briefs, documents, publications. If they published their record in a persistent, trusted repository, such as Zenodo, and they put the grant agreement number there, SoilWise is automatically harvesting this and making it available in this catalog. So it's really indexing the record, is not storing it. And this becomes then available to the user. So it's really, it doesn't want to replace any repository. It creates like a discoverable layer on top of the existing repository. So the user can have a one-stop shop, let's say, for the soil information. And of course, this will become part of the EUSO later. And besides this, we are also working a lot on these FAIR guidances that can also be found in Zenodo on how you should publish your records in a way that become part of SoilWise. And also on this chatbot, because we realize not everybody want to scroll to a lot of records in the catalog, but want to have the information in a more digestible way. So this is built on top. And I would like to also describe these principles to be very clear what we do and what we don't do. So SoilWise is main objective is to provide a single access point for soil data and knowledge, to index this available data and knowledge that is out there in different repositories and connect with existing catalogs. Also, a lot of projects are producing their knowledge hubs, so we're also harvesting this fully. And our intention is to make the life of both the data providers and the users easier through this interface. And what we definitely don't do is we don't copy or store any third-party data. We only harvest the metadata. We don't control or judge or steal the data. So we don't work in any way at the data level, only at the metadata level. And we also don't use any data without consent, even for demonstration or any other purposes. Maybe shortly what we have done until now for the 2 cycles before moving to the 3rd cycle. We have now 3 working prototypes that are delivered. We have more than 30,000 metadata assets from both datasets and knowledge that are curated in the catalog. We're actively harvesting more than 9 major repositories and sources. Maybe the more innovations for Single Grant Agreement is this catalog and all the things that are going in the backend. So we are taking the records, we're also harmonizing them. We are augmenting the metadata so to make it more visible for the data providers. And this is the the main thing, and it's the most visible thing, and the one that becomes part to ILVO. But we're also working on this chatbot to help get the information in a better way, and also the soil health knowledge graphs that also helps the semantic search and use vocabularies for the interoperability. And this is also integrated in the catalog. We really believe, and we learn from the first years, that in order to develop a very useful and functional soil data knowledge infrastructure, we need to have collaboration, but also benefits with all involved stakeholders. So the data providers, the users, the European Commission, and the ambition they have, we all need to sit together and work. We do this a lot in the clusters, but there's still a lot of opportunity to work together. This is also what I explained, that we published this guideline of how to make your records fair in the data sets, and also with the websites of the projects that can be found. And maybe very shortly to just show the catalog and the chatbot in short. So they're both can be found on the website. You can access it directly, and you can go and check it. And you have two ways to search. So with the catalog, you are basically using keywords to search for a record that you are interested. And with the chatbot, you're using more natural language. Then in the catalog, as I said, it's a single access point for the European soil data and soil knowledge. It's bridging different repositories and soil mission project outputs. It's focused on the metadata. And this interface is just released a few weeks ago, but we're working a lot on it to even make it more useful for the users. So in short, this part is the metadata catalog. Under it is the soil companion. You can find also some statistical information in the homepage. But then once you start searching, you have the full text search on top. Then you have different filtering options. So you can filter on language, license, different projects, source, keywords, and so forth, temporal, spatial filters. And then you can see the results on the left-hand side with minimal information. You can scroll through, and then if you open the results on the right, you can see all the metadata from those records. Once you want to access that data set, for example, you will go to the DOI, and then you leave the catalog and you actually land on the repository where the data set is, and then you follow the steps there to download it and use it further. So as I said, it's really indexing where the information resides. And there's also a help where you can find all the information of how this works, a type of user manual for the catalog. And then in the chatbot, as I said, you can write more natural languages. Here, just to give a bit of information, because when people hear that we have a chatbot on top of the catalog, maybe they think it does some magical thing, and why would you even use the catalog? But how it works is that it is based on some existing LLMs. Right now on OpenAI, we're talking with the commission. I know there's some works in developing their own LLM, and as soon as that is available, we would definitely want to move to that one. Then it has a rack system in which there are 100 or so documents that are curated with the soil experts. These are, let's say, some of the main information about soil health that is fed to the chatbot to kind of set up the context. And then it uses a sort of tooling, and it links to the catalog resources, to the vocabularies, the knowledge graph on soil health vocabularies, and other tools. And based on the questions and the inquiries, it goes through these tools and gets the information and makes it more, let's say, relevant for the user. What we really want to create, we don't want to compete with any LLM that is out there. We don't think that we can outperform any LLM. What we want to do is to create a chatbot that uses the information in the catalog that we know it's relevant, it's curated, it's very good, and makes it available in a better way. And also it shows a bit more transparently how why these responses that are generated, where are they coming from? It gives the sources of the documents that are in the catalog, so that the user has this full image of why these responses got there. still needs a lot of work to make it more relevant. So actually, we are always in search for soil experts or any type of other expertise that is working in this field to give us information about if it's good way, how we're going, how it can be improved, because this can be further improved. I won't go a lot into detail, but on the interface, you have some information about how it works. You can, for example, select location, and it contextualizes the responses on that region. So it becomes a bit more specific. You have also some insights, so it uses also the Wikipedia and other tooling that I mentioned to make them even more relevant response. And then in the interface, you can see that it's basically you're chatting the same like everybody does now with the LLMs, but you also have some template questions to help you navigate through the response. And importantly, you see lower, we have a feedback tool. You can simply just use thumbs up or thumbs down. This feedback, we actually really look into it and we use it to further improve it. So if you don't have time, just a thumbs up, thumbs down, it's enough for us to know what is produced. But you can also write something like, this is incorrect, it's too generic, it's off topic, the tone is not good, or other information. And all this kind of feedback is continuously revised to be improved. This was in short what we are working on and what we're trying to do. There are way more out there that I didn't cover, but we're now working on a user manual where we basically describe everything that we are developing in a layman's language, so then would be available for everybody. And we're also gonna show the life cycle of data sets. We're gonna show since the data provider put it in, for example, Zenodo, what happens through all the steps, explaining actually also how the components work, so how the harmonization happens, how the metadata augmentation happens, and all these things we're gonna show through the lifecycle of data sets from publishing to this repository to getting to a user out of the catalog. And then maybe everything is a little bit more clear, but I wanted to share a general overview about the project up till now.
Thank you, Radu. I think it's impressive, even in a short presentation, your work and the number of items you have in the catalog, and also the chat box that I must say in the last 2 years have become, besides I had some resistance, but in a very short time we start to use them. And actually it's very useful, even if have to be treated with some attention, because there is a number of but a question before moving to the next presentation, just maybe to have also your personal view. What do you think is the most valuable result achieved so far? And also, what do you think, what you will focus the next effort in the next project, or the next for the people to come? Let's say, what do you think are the gaps that are still there, where more work? And also, what personally do you think should be improved beside, the project?
I think I already can easier respond to the second question, but I will start with the first one. I think I cannot just mention one of the component which I think it's the best result, but I think the best result is the integration of all these components. In the first iteration, we worked a bit more isolated, so we have the developers working on these separate things. Now we got everything a bit more together. We also sit together with all the developers and the work package leads and so forth, and we drafted the vision of what we want to produce by the end of the project. So we have a really good idea what we want to deliver at the end of the project and to EUSO, and what would make us happy if we can achieve this. So now we have a very focused targets toward the end of the project. So I would say what we delivered until now is the best result as a full package with the catalog and everything that goes behind, which is not seen by the users, but there's a lot of work going there. But I think the best result will be in the next iteration. And what can be improved in the follow-up projects. We already see that we can go as far as we can go with the effort and time we have, but we already see what else could be further developed and improved, and there's a lot of things. And when we deliver the development to JRC and EUSO will also deliver a documentation about all the things we need can be followed up. So on the technical side, there is still a lot of work that can be followed up. But what I would rather hope that the Commission will do is not to necessarily follow with the SoilWise 2.0 and build on what we did, but maybe with a CSA project, because equally now we have a nice discoverable layer. It works pretty well, but equally we need to do a lot of capacity building training with the soil experts, the data providers, what are the best practices, the metadata for soil that needs to be used, the shared vocabularies that should be used for interoperability. So I hope that this would be followed up, the training, the stakeholder engagement, the discussion, the putting together the community and align on really building this ecosystem. So we'll see what happens.
Thank you. Thank you. Very clear. And I think there are some awareness on the need of working with communities that is lower in somehow than the technical side. Sometimes let's say the social skills are needed also to agree on what we share, how and how we read. So it's a different layer, let's say, of challenge. So now just also I think they read very well the two presentations together. So I give the floor to Octavian Chiriac that will present AI for soil health and specifically soil health data cube. So Octavian, the floor is yours.
Thank you, Giovanna, for the introduction. And I will present today one of the main outputs of AI for Soil Health project, which is Soil Health Data Cube. And as you can understand from the title, I will speak mainly about soil data in space and time. So first of all, let's have an overview of the project. In terms of goal, is to build an open European infrastructure for soil health monitoring and forecasting using AI tools. This is the reason was already presented by Radu regarding the soil degradation, because due to the pressure for food production, for climate change, water availability, and loss of biodiversity that our soils are affected by. And how to do this? We combined data from the field with data from the satellites or remote sensing data using machine learning models and creating this way maps at European level and forecasts. Concerning the impact that we are expecting is to use these tools for the land management as farmers or policymakers, and to give more tools to common agriculture policy and for sure for for European soil monitoring law. My presentation will be focused on three specific points of soil health. First of all, definition and how to monitor it. Then the tools that were developed in the project, specifically soil health data cube, and to the limitations, because as research project, we have to be aware when to use these products and when and what are the risks. So first of all, there is no unique definition of soil health. If you ask to 10 different peoples with 10 different backgrounds, you will obtain 10 different definitions because it's a very complex system, the soil. I would like to make a parallelism with the definition of human health, that is the complete state of mental, social, physical, and social well-being. In the previous century, the definition was lack of disease, and for soil health, we are still using this definition. So lack of soil degradations on chemical, physical, and biological aspects. So the project have the goal, the objective to develop a framework and a data sets on soil health, and to provide also some guidelines for future development. How? Building an open access infrastructure, providing soil maps that will be updated, and this way giving the tools to also monitor the state in the previous 20 years, and with new data sets we hope in the future 20 years at European scale level. So as I said before, the main output that I'm focused on is a digital tool, Soil Health Data Cube. Using machine learning models, specifically random forest models, we were able to provide maps at very detailed scales where data is not available. As you can imagine, it's not feasible to take samples in each field in Europe, so we have to use different tools to have at least an idea of the soil health state in a specific area. But when we have the data, we have to translate them, to translate it in information, and finally in the decision making for policymakers and farmers. So this is next step. And one of the ways to do that, obviously, is to provide the data, but then also to provide the tools to interpret the data. And I will make I will tell you more in the next slides about this. Obviously, putting together different states, different backgrounds, different stakeholders, to do it, it's mandatory to collaborate. So to collaborate at the European level as data, soil data, for example, Lucas mission, but also at national scale, sorry, to use the data for a European interest. The limitations of these products are due to the uncertainty and biases starting from the sampling points, where the sample made, then how the laboratory did the analysis, different protocols or different methods to compare, and then the uncertainty due to the models. And we provide this information, so to give all the information that the decision maker will need to understand if the data is the right one for the specific situation. And one another limitation for sure is the gap of the data in terms of space, mainly, because there are some areas that are not don't have enough data, but the biggest gap is in time, because we don't have let's say long-term data sets to provide information in time. There are projects ongoing on this. There is a scale mismatch between field relevance data, for example, which practice the farmer should adopt to increase carbon stock, or the interest of European level, let's say, incentives to increase the carbon stock. So the scale is different. So also the information that the different stakeholders needs is different. Last but not least, we have to speak about AI, because it's the first topic, at least on LinkedIn. So today we will mention it because we also use an AI tool. And to make it trustable and transparent, we will publish the code source so anyone can use it and improve it. So this way, the information provided will be credible. And what open data means, as you can see, it's the core mission of our research foundation. It means that anyone can access, use, and share it. So it's based on FAIR principles, as already Radu explained, on CARE principles, and on CC BY lessons. I would like just to highlight one of the FAIR principles, which is interoperable, and is the most critical one, because putting together different data sets, the problem is that often they are not communicating each other. So some formats are not the best for data sharing. For example, PNG files or CSV files are not so adequate for these principles. Let's have a look to the main outputs for now related to Soil Health Data Cube. We provide maps of soil texture, so sand, silt, and clay, soil organic carbon and soil organic carbon density, which is the most interesting for carbon credits, and also provide pH in water and calcium chloride, bulk density, and extractable potassium. In addition, there is soil type classification and the relative probability as output of AI for Soil Health project. How it works is consisting of two main data sets. One derived from remote sensing, so Earth observation data cube, that combine data sets from Landsat, from climate variables and morphology of the soil, with the observations on the ground, so point soil data, mainly from Lucas, but also from other research projects, national inventories, and so on. And together, by merging this data set, the base input is the training matrix used in the machine learning models to create the maps at European scale in this case, and providing also an interval of uncertainty to better interpret the output. So for now, we have 24 years of time series till 2000 to 2024. The uncertainty at pixel level and a pixel size of 30 meters resolution, and 4 different depths. Where you can find Soil Health Data Cube, there are different sources, as the manual, which is, let's say, more detailed instructions than the presentation today. The web platform, EcoData Cube, that integrates soil properties with different maps, for example, related to NDVI and other indexes or topography, and to have a better overview of the data available. And the catalog, if you don't want to use the web platform, so the WebGIS platform, you can use on your own software, for example, QGIS or other softwares, by downloading the data from Stack EcoData Cube, or using the link of the cloud optimized GeoTIFF, so you can easily visualize the data on and combine with your own maps or points. As Radu said, the co-design is something that must be repeated in each cycle, and also in our products. So we are asking you a feedback for SoilHead Viewer, which is an AI assistant that uses the data from SoilHead Data Cube to provide information on specific questions. For example, what kind of crops can be cultivated in my field, or what is the trend of carbon stock in the previous 20 years in this specific point. So to make the data more digestible to non-expert users. And continuing, we are searching for data. So if you have more data points to help us to improve the maps, we are collecting them, and you can decide if you want to share completely, partially, or not share the data. And if you have already products, pan-European layers, we can integrate them in Ecodata Cube, so to have a wider infrastructure in this sense. And if you want to join in more workshops, to the one that we are doing today, we have a conference. We organize a conference in December in Thessaloniki, in Greece. And if you want to know more about the outputs of the project, because it will be the final event, we will love to see you there. And thank you for attention.
Thank you, Octavian. I think it was very clear, and it seems really to mirror in a different way the presentation of Radu. So we have a catalog and a call for input for the soil companion, and we have a more data-oriented tool, and also a call for input more on testing and giving feedback on the use of soil health, soil view. I think I will ask just to start also to you as a personal view and project view. So what do you think, okay, is impressive, the work is clear, the aggregation of data and the possibility to have a look from Europe, on soil property. But what at personal level you think is the biggest achievement, and also where do you see more effort needed also from the point of view of using this tool in the future for, let's say, policy at different scale, from region to national, European scale?
Okay, so we have only 20 minutes, so let's try to. And I think, in my opinion, the biggest achievement is not only the data produced itself, but the aggregation. So the value of putting together different data sets, different data sources, as the project SoilWise is doing, trying to merge all the outputs from different projects as AI for soil health. And Ecodata Cube is synthesize this. We have soil properties, we have environmental properties, we have also agriculture maps, for example, the crops available. So in my opinion, this is the additional value, because in some cases 1 + 1 is not equal to 2, but 1 + 1 is equal to 3. In this case, merging different data sets, the output in terms of additional value can be definitely higher than the single one. No? So having a whole overview, for example, and I have this bias of being an agronomist of field level. So having having all these data sources can be very useful for decision making, because there is the trend that can be observed from different point of view, from soil, from climate, for the crop, and this can help definitely the farmer or who has to make decisions which is the best one. How can this be improved? Definitely engaging all the people involved in the process. Being a research project, we are involving a lot of researchers and trying to involve more policymakers and farmers as associations. And this is one of the biggest, let's say, the biggest difficulties of research projects, because to transform the research, to transfer it into the ground decision, there is there are more steps to do, and especially dealing with people. So it's more on, let's say, social aspect, as you said before, to work on this, to teach, policymaker or farmers how to use these tools and make the tools that can be somehow user-friendly for them, and then to translate into decisions that can be public interest.
Thank you. Thank you. I think you answered partially also to this question. There is a question on the chat box. How do you think how precise the data should be that the soil health data can be used for policy? So from my understanding, you have partially answered to this. So on the either how precise should be or how uncertainty can be communicated in order to then policy to make decision based also on the degree of uncertainty. So I don't know if you want to add something, and then we go to the first question. Maybe that was for Radu.
Yeah, it depends a lot of the purpose of the decision. For example, if I want to know what is the specific content of specific property, there is an interval of uncertainty, so it's better to directly take a sample and send to the lab. But if the decision concern what type of soil texture I have in this area, definitely the outputs of the projects are very useful for this purpose. And I don't know if this was
I think it was clear. It depends of the kind of data they want to use.
Also depend of the space scale. If we are focused on field scale, there is a high uncertainty. If we are focused on the regional or even national scale, the uncertainty obviously will be reduced.
Yeah. Because as I mentioned at the very beginning, this project takes more an European perspective than a very field or regional perspective. That could be the next step for this project, let's say, to improve the also the precision compared to lower scale. I go back to Radu, try to report the question, but also maybe to broaden it. So it was a question regarding whether you have thought about development with ARIES tool for C. I think is a specific catalog or tool especially dedicated to sea and water that I know is another mission, the ocean and water. So maybe the question can be broader. To what extent the catalog for soil and the data for soil can be together with, there is the mission on cities, that urban and also mitigation that is connected with soil. There is the mission on ocean and water that is connected with soil because there is erosion. So I think maybe if you know this tool or you have been speaking with other network on how to integrate soil health data with other similar or initiative in different field, because also the nexus between soil, water, and so maybe just not with this tool in particular, but more broader, maybe also with other network and experiment.
Yeah, so the catalog is really aimed to have the one-stop shop, let's say, for soil information. So we're trying to target as much as possible soil, not to disregard other things, but just to make it very relevant for soil. But how the harvesting works, it's an automatic process. So we also harvest records that are not purely for soil because there's so many interlinks. So we have research on environmental research down. We have also climate and maybe even ocean or marine research that are there because the records that we got, they had some components that fit in the harvesting strategy. So for example, if you have a soil keyword in a certain repository that we harvested using this keyword to identify these records, they will be part of the catalog. Even maybe they're not solely on soil. Maybe soil is just a pilot in a research where it targets also other things. So the catalog will offer broader resources that can be used, but we try to focus on soil. And then the other thing is what we do in the back end to help the ranking in the search functionality. We really think that the users that will likely visit the catalog will be soil scientists and then policymakers working on soil laws and so forth. So then the ranking should bring these resources on top. Doesn't mean there are not existing other resources, but we also see there's more and more cross work also between the missions. For example, now there is a call between mission Climate and mission Soil, and I think this will follow up. And also, I think there's a lot of trying to understand from all these missions how they manage the data. And at one point, we need to have more alignment and get to a more one framework that can be expanded to other regions. So in short, we know we don't have particularly targeting other domains, but yes, we have records that are important or relevant from other fields, while we try to make it very soil centric, of course.
Thank you. I think it was clear. Now we have a last round, and also because I think you have made a really great presentation and a lot of effort on answering to the question. I will give you the floor to choose the question to answer, not because also I think there were 3 questions I prepared. I hope that you can see them now. But we have speak about skill and competence, at least partially during your presentation. I like the second also as a public good that was touched upon, and I think will be interesting also to imagine what will happen in the next 5-10 years, and these artificial intelligences go to a speed that is hard to sketch what will happen in the future, but it will be interesting from your expertise, what we should look at. So what sign we should read to understand the direction we are moving. That could be a technological, or social, or political sign. Let's monitor the platform. Who owns the data? Who has artificial intelligence tool, or how data are shared? So these sign to monitor are, let's say, trend on the economic or political field that can give us an intuition or the direction we're heading. At the same time, it will be interesting to know about trust, uncertainties, a bias, as is always a hot topic for data handling and sharing. But we have just 10 minutes. We have to pick one question for each of you, and I will I will leave you free to pick the question that you like the most, as is the last question, and you have 5 minutes to answer. So you can pick the one that you prefer, or the one that is easier to answer in few minutes. So I will start with Radu first.
Okay. I like your question. Actually, I would like to touch on all, but of course I cannot do that. Maybe what I really like this phrasing of soil intelligence as a public good. I think this is really interesting because soil health, as we know, is really linked with food security, with climate, biodiversity, and so forth. So it really needs this soil intelligence, or these platforms that try to help getting this soil intelligence out there and applicable. It needs to be very transparent. It needs to be very interoperable. It needs to be as useful for the ones that produce the soil information as for the ones that use it. And yeah, this is the only way that this will work. So everybody should understand what is the added value to invest into this. So the data provider should understand that if I publish my data in this way, I will have more impact because it will become more available, more visible to a lot of stakeholders. It will actually help me reach those objectives. The users will understand that they can come to this platform and find the resources to use. And we're actually working, and we do a lot of AI to help improving this, but we're looking on how to involve the community in helping this platform. So to just give a practical example, and then I will finish, is that once we harvest these records, we harmonize them to the SoilWise data model, and then we augmentate the metadata, because a lot of records don't have complete metadata. They don't use the same vocabularies, so it will become difficult later to be used. So this is the AI improving the metadata, but now we want to involve also the community, where they can suggest, correct, edit, improve the metadata themselves. So then we have 3 layers. We have the original record, we have the AI improved metadata information about the record, and then the community one, which both correct the AI and also improve it further. And all these 3 layers should be visible for the user, and the user would know the data provider gave this information, the AI improved it with this information, and the community further improved it with this information. And then it's a really, let's say, co-creation of the soil information of the platform, and the platform should just be the mean to allow these actors to work in getting this soil information in one place. So this is the goal.
Thank you. Thank you. And I like also public good is the commons in public policy and recognize. I think underneath there is the being afraid of if land is but there are commons in history, you know, recognizing something as a public good. So I think there is a discussion, a debate to be open on what is a public good, a commons, and the sharing, and to what extent can be used this terminology also for infrastructure and data. But thank you, very clear, and I will give the floor to Octavian for picking up a question and and a brief answer.
Okay, a random choice. So I will answer to the first one regarding the skills and competences with an example. When I started my PhD 4 years ago, so where was the beginning of ChatGPT, you know, so the revolution was starting. At least the use of AI accessible for everyone, because the development is related to many years of previous research. But the web allowed to feed these tools with a lot of data and to provide more detailed answers. And what is missing right now, definitely the skills and knowledge related to how to use them. We are research projects, so we provide a lot of outputs and a lot of tools and data sets that can be applied in different contexts from different users. But what is lacking is not the technology available for the farmers or for the policymaker, but the way to communicate these results to them. For example, using a tool like a chatbot that can translate huge amount of data and research outputs in a plain language that everyone can understand and tend to decide. I'm observing a lack on this aspect because the technology is going so fast. Just think 1 month ago, cloud updated with another chatbot, the same in OpenAI and other tools. But how much time do we need to adapt to understand how they work? This, I think, is a lot of work to do from the university's side from the policy, also from the research side, to communicate to the people what are the advantages, the disadvantages, the risk of using these tools, because are mainly statistical models, very, very complex each day, but their reply on a probability of one word to the sequence to another. For that reason, for example, at least in the chatbot that we developed, based on the outputs of the project, we train it with data directly we train it directly with the data available from the maps. So to reduce at zero the hallucination problem, because it's a big issue. No, they were trained to answer to each question, even if the means to invent it. So to be concerned about what are the outputs of these tools and what are the limits, because cannot do everything. They were designed for specific tasks, at least the outputs from our projects, and must be used for that specific task.
Thank you. It seems they can do everything, so that is the trick. I know.
This is marketing.
But I think they are good for people that already know. They are dangerous for people that, they read and it's not clear what is wrong and what is right. So that is I think the danger, because if I speak about an argument I know, I realize what is wrong.
Yeah.
If I ask about something I don't know, it's hard for me to distinguish between hallucination and true. So I think it's a
For that
useful
reason,
tool.
we need the source
Yeah.
of the information.
Yeah. It's a long discussion, I think, for the next webinar on limits. But thank you for, I think, very clear, and also for not data scientists or data soil scientists. I think it was a very, very useful presentation to get to know the different tools on the point of view of opportunity. They're great, that is evident, but also the risk that we should take into account, and also how to fill the gap in order to use them in the best and proper way. I also thank OpenGeoHub and Viola for the organization of this webinar, and I hope you have a nice week, and thanks again for your availability.